In this lesson, we'll explore creating a 2D contour toolpath. We'll start by opening up the part called 2D mill fixture. Now when we open the part, you'll notice that it prompts you to change system configuration. That's because we were in inches and this part happens to be a metric part, so it's asking you to load the metric configuration file. I'm going to click OK, and the part gets brought in. Now you'll notice down here the scale says metric, so we are in a metric part. And if I go to the Home tab and click on Analyze Entity, I'm just going to grab one of these edges, and we'll see that it's got a two-dimensional length of 200 millimeters. I want to point that out because I want to switch this part from metric to inch. So I go to File, and then I click on Configuration. The configuration file comes up, and down at the bottom under Current, it's currently looking at the MCAM-X M config, and that M stands for metric. I can use a pull-down menu and choose the inch version, and it warns me that changing configuration units is not recommended. Specifically, only the geometry changes. So for example, if this part was already programmed and I had a 12 millimeter tool, it's not going to automatically convert that tool for me. But at this point, since it's just geometry, we're going to be fine. So I'm going to click OK, and then OK. And it's asking me here if I want to scale the current part to inch. I'm going to say yes. What that will do is it'll convert everything over to inches. If I said no, it would make this 200 millimeter edge to be 200 inches, which is obviously what we don't want. So I'm going to say yes. The part gets converted, and you can tell because it's essentially a scale feature, which makes a change to the part. So you can see that the part is now in the result color. If I right click, clear colors, and then go to Analyze Entity, we'll see that this is 7.874 inches. And in fact, we can change just the value or the units of the measure tool to millimeters, and you'll see that it does in fact read 200 millimeters. Now if we briefly went to our levels manager, you'll notice that in this part we have some other geometry. For example, we have the guard, and as you can see, the guard is what this fixture is holding. We have a vise, and we have fixture wireframe, so basically wireframe geometry that we could use if needed. I'm going to turn off these levels for now, so we're left with just level 1 and level 10, which is our fixture plate. Since we opened up this part and we didn't create any toolpath, so we haven't designed it, it's a good idea to go through the levels, the planes, to see what else is going on. So if we go to the levels manager, which we are here, we saw the levels. If you go to the planes manager, we can see that there's a plane called fixture plate plane, which I'm not sure what this is. And if we zoom out, let's see here, you'll see that there's a plane here called fixture plate plane. And what this is this happened to be the location of the origin for the part when it was a metric part. So this has to be corrected, and we will address this later, but just identify the fact now that fixture plate plane is a little off the part, so we'll have to update that later. On our toolpaths manager tab, you'll notice that this is completely empty. So the first thing we're going to do here is pick a machine. If we go into the machine tab and I go to mill, you'll notice there's only a default option here. Now this depends on your install and what type of system you're working. There may be default machines already listed here, but you could go to manage list, and in this list on my particular machine I have 2 mill default machines and 2 generic Haas machines. I can select them both and click add. The only thing this is doing is populating these machines into my drop-down list, which means now if I go to the mill tab, you'll notice there's 4 machines here. So you'd want to put on this list the machines that you intend on using. For example, if you're only using one Haas machine, have that be the machine that's listed here as opposed to all these machines. I'm going to pick the default machine, and you'll see what happens here is the default machine now gets populated into our toolpaths group. Now that we have machine selected, you'll notice under the mill group there's a Toolpaths tab, and this is where we access the contour toolpath when we were exploring chaining a little while ago. But also under the utilities section is the tool manager. The tool manager is where all the tools will be displayed that we use in our part. The lower window down here lists a library, and the upper window lists the tools that are currently in our part. I'm going to open up a library that's available in Mastercam. It happens to be in my downloads directory, and it's called Mill or MCU Fixture Tools Inch. We also have a metric version of these tools as well with the same numbers, so feel free to use that instead and go through this exercise in metric. As you can see, this library now lists my fixture tools library, and there's about 8 or so of these tools. I'm going to grab them all, hit the arrow button that brings them up into my part. And the way I look at this is like taking all the tools out and laying them out on your bench, and now they're ready to be used. You don't have to use them, but they're all easily accessible and ready to be chosen in each toolpath. Let's click OK here, and now those tools are in our library or in our tool manager ready to go. Next thing I want to do is create stock for this part. So if I zoom in, I can create stock by expanding the properties section of my machine group. And we have an option here called stock setup. By choosing stock setup, we'll see here that I can type in the values for the stock I want, or I could invoke the bounding box function, which is itself a separate function under the wireframe tab. But by doing it here, it will actually create the rectangle around my part, but also populate these values here. So I'm going to go into bounding box, select the geometry I want. I'm going to tell it to create lines and arcs, and in this case we'll do corner points as well. When I'm done, I click OK, and then click OK again. And you'll see here that the red dotted line defines my stock. Now the red dotted lines are not selectable. What we see here is the wireframe geometry that the bounding box tool created. Now let's move this wireframe geometry to level 106, which happens to be all of our fixture wireframe. So I can select all of these, and there should be 4 on the top, 4 on the bottom, and then the 4 edges. And of course the points. Now that they're selected, I right click, I go to change level, and over here I'm going to move them to level 106. And in a case where this is grayed out, it's because you use active level is turned on. So I'm just going to change that to 106 and click OK. So now all that geometry is turned to level 106, and if I hide it, you'll see that it's now disappeared. Before we hide it, let's use this location for our plane, and we can update our plane. And to do that, I'm going to go to the Planes Manager and find that fixture plate plane. If I zoom out, you'll see it over there. And with it selected, I'm just going to go down and select a new origin. Let's zoom in here. Grab this corner right here. So now our fixture plate plane is updated. And since this corner is going to be butted up against the vise, we should be good. What I'm also going to do is make sure the fixture plate plane is set to the construction plane as well. I'll go into isometric, zoom in a little bit, and I'll update this view sheet. So let's go back to the levels. We'll turn off level 106. And let's create a contour toolpath. So we're going to go into toolpaths, and we're going to select contour. Now we saw the chaining before. We're going to go over to solid chaining since we have a solid. And here I'm going to make sure that I grab the outside edge. And notice There's a bunch of different options. I can choose this face, that face. I'm going to move so I can get the outside preview. And I'm going to make sure I click closer to this endpoint here because that's where I want my chain to start. Or let's actually say we want the chain to start over here. So we'll do that. The chain would start right there. And as long as I get one green arrow and no red arrow, it goes all the way around and it finds itself as a closed contour. So that's good. When I'm done, I click OK. So this is the tool path that we're using. This is the chain geometry that we're selecting. And if I wanted to, I could go unselect it and reselect it. And the way I utilize this tool path is I work my way down the left. So next is a tool. Now, since we already added these tools to our file, I can simply pick one of the tools from the list here. I'm going to grab the 1/2 inch tool. I'm going to type in for a comment, contour outside, which will show up in our posted or code as a comment. We have our feeds and our speeds, which we can update here. Right now, we're not going to worry too much about the actual speeds and feeds, but we'll see how these work in the later lesson. Working down the left, we can choose a holder if we wanted to, and we can go right to cut parameters. So here's where we could indicate what is our cutter compensation, to which side, what type of contour it is. More specifically, if we want to leave something on the walls and the floors, we could do that here. I'm going to go right down to lead in, lead out because I don't want this to enter right on the edge of the part. I'm going to turn on lead in and lead out, and I'm going to use the default settings here, which means I'm going to have a linear line in and then an arc in. It's going to cut, and then I'm going to have an arc out and a linear out. Let's skip breakthrough, multipasses, and tabs, and we'll look at those later. But we'll go right down to linking parameters, which we briefly discussed earlier. Working from the bottom, the depth is going to be incremental, which is relative to the geometry I selected. Since I selected the bottom of the part, that's exactly where it's going to cut to. We may want to revisit this because if you recall, this isn't a vise. And if we cut to the bottom of the part, we might cut the vise, but we'll look at that in a minute. The top of stock is set to absolute 0. And if you recall, the top of stock is right there. That's our current WCS. So that's good. And if we didn't know, or if we wanted to double check, we could just hit top of stock and then pick here, or pick any one of these, and you'll see its top of stock is 0. Feed plane is 0.2 inches above the top of stock because it's set to incremental, and retract is 0.25 above the top of stock. Next thing I'm going to add is a clearance value of 1/2 inch. That's going to pull up 1/2 inch above Z0. When I click OK, the toolpath gets created. And you'll see it feeds in, it arcs in, cuts around, and then it arcs off. In the next lesson, we'll look at editing these toolpaths to make them more reasonable. For example, we could add depth cuts or multipasses so we're working our way from the outside in. And we could also address any issues with the depth if we might be going too deep.